Hello and welcome. This is Mary Magnuson, and on behalf of the Blandin Foundation, I'd like to welcome you to today's webinar about making 700 megahertz wireless work in rural Minnesota. This is one in a series of monthly webinars we're offering for our Blandin broadband communities and open to anyone with an interest in using technology to improve community. Before we get started today, I'll point to the chat box on the lower left corner of your screen. To interact with us at any time during today's webinar, you can simply type your question or comment into the chat box. Today we welcome Kevin Larson, the CEO and General Manager for CTC. Kevin has over 30 years of combined experience within the telecommunications industry, including operations, sales and marketing, public relations, and member services. He serves on numerous boards and committees, including the Board of Directors for the Rural Telephone Finance Corporation and the Minnesota Telecom Alliance Legislative Committee. Also, as a special last-minute added bonus, we also have with us today Tamara Johnson, President and CEO of Dryad Communications. Dryad is working to bring broadband access to rural communities, including Minnesota, Nebraska, South Dakota, and Native American reservations. Tamara will be sharing a summary of the work Dryad has done using 700 megahertz spectrum to bring broadband to rural areas. But first up, Kevin is going to tell us about the potential for 700 megahertz wireless for rural Minnesota. 700 megahertz is located in the sweet spot of the wireless spectrum. It combines both power and bandwidth, making it an excellent choice for rural wireless deployment, and as a licensed frequency, interference is kept to a minimum. CTC owns the 700 megahertz spectrum across a swath of central Minnesota and is making plans to deploy this technology. They have filed an expression of interest for the prospective FCC rural broadband funding. Kevin is also going to tell us a little about the advantages of the technology and the barriers to deployment, and about how to find out who owns the spectrum in your area and discuss what community leaders might do to encourage deployment across rural Minnesota. Kevin?
Thank you, Mary, and welcome to everyone. And
there you go.
All right. What I thought I would do today, and I'm certainly hoping that I don't offend anybody, but I thought I'd take a step back and talk just a little bit about what is 700. And so, and this is my first webinar I've done, so Mary's stretching my my window of operations here. So does that show up now, Mary?
Yes, it does. You're doing everything just fine.
All righty, thank you. Again, I don't want to offend anybody about your knowledge of 700, but I thought I'd step back a little bit here. So I thought I'd go through this slide here and do a little education. So the 700 megahertz obviously was part of the television broadcasting, and if you've had enough birthdays like I have, you'll remember watching the UHF channels back in the day. And so the second bullet here is the 700 band is divided into two categories. You've got the lower band and the upper band. And the lower band has 48 megahertz of spectrum, and the higher band has 60 megahertz. In 2002, they reallocated the lower band, and that was originally used for those TV channels of just 52 through 59. The advantage of 700 megahertz is that signals travel longer distances than higher frequencies. And you know, there's AWS and PCS and all of those spectrums are higher frequencies. Networks using this spectrum require fewer cell towers than if they are able to reach farther. But in addition, the spectrum is able to penetrate walls easily, so that's why it makes this kind of the sweet spot of a spectrum out there. However, there's a disadvantage when you've got distance and penetrating qualities. There is limitations of the bandwidth available per channel. And of course, higher frequency bands offer greater capacity, but the signal travels shorter distances and then has more difficulty penetrating walls. So when you add all this together, you can see why 700 is kind of a sweet spectrum. But again, anything that comes with pros, there's some cons that come with it also. CTC owns some spectrum. We own the lower 2 channels of 700 in the C block, and there's 6 megahertz channels. These cover the counties of Isanti, Morrison, Mille Lacs, Kennebec, Pine, Lower Cass, Crow Wing, Aitkin, and Carleton counties. And we're currently using it for fixed wireless broadband. We put our equipment in about 6 years ago, and obviously in this day and age that equipment is aged, and it has limitations with the bandwidth available to the customers. Basically, we can usually only get about 768 kilobits or maybe 1 meg to a customer. However, they can be a long distance from the tower or the closest community. And like I said, the equipment is aged and quite honestly becoming obsolete. That's very difficult to get parts for. We are currently testing some new equipment which has 4G LTE capabilities. Now, due to the technology, this equipment has significantly more bandwidth available to the customers, even though you're still only using those 2 6 megahertz channels. So technology has catapulted the equipment these days in the 700 spectrum to be much more user-friendly and so forth. But the current drawback on the equipment that we're testing, the equipment is designed for 12 megahertz channels. And if you look at the very top note, we've only got 6 megahertz channels. So there's an issue there. And right now we're working with the vendor. And they say that the radios are capable of 6 megahertz channels, but they just have not released that yet. So quite frankly, CTC is still in a holding pattern in waiting for equipment to replace the original equipment that we've got on. I just also noted at the last bullet point there that AT&T owns the 700 megahertz. They own the 2B channels, which are side by side to our C channels, and they own that over the top of us. And Tamara's going to have a better map to show you, but this is CTC's area that we own spectrum in, and that's the coverage area that we're licensed to. Next, talking about, Mary asked me, she says, well, how do you know what's available out there? Well, I am unaware of any available 700 licensed spectrum today. It's, as far as I know, it's all purchased. I wanted to give you some results. Back in 2008 auction, which was, I believe, auction 73, they sold quite a bit of this 700 in the B and C and D blocks. That total winning bids, as you can see there, was $19.6 billion. It was a very enthusiastic auction, I guess you would say. And there you see where Verizon and AT were the big winners. They bought considerable license, but there was other companies that did also. And you'll see down at the end of that paragraph there that AT&T won about 227 B block licenses. So significant. For a lot of smaller companies have C block, but they were able to purchase the B blocks. I put the website where you can go to find licenses, but I'm going to be very straightforward. It says it's very difficult to navigate. And quite honestly, when I go search there, I have very limited luck, and therefore I use a consultant if I need to go find if there's licenses available or who owns a license. And I'm saying that because we are a wireline company here, and we're relatively new to the wireless business. But I don't spend a lot of time on the FCC government site, and I find it, personally, I find it very difficult to find anything on there. But that's one of their website. One access to their website to the wireless environment. And through being a part of a national association, I've been watching. The 600 megahertz is going to be released here. Hopefully, it'll go up for auction sometime in 2015. And so if we back up 25 years, the original cellular companies, the AT&Ts and the Verizons and so forth, they originally started rolling out cellular service on the 850 megahertz. And now you see that we've got some 700 out there, and now they're releasing the 600 megahertz. And any time that you continue to go down that spectrum, obviously you will get spectrum that can travel further. But then again, there'll be some limitations on the ability of the capacity of that. However, you know, we always are grateful in this country that technology continues to find ways to grab more out of that spectrum. But right at this point in time, CTC is in a holding pattern. We'd like to change out this older equipment. We want to move into the 4G LTE equipment. And there is equipment available by other companies. Some of it's a little more expensive, and it's mobile. But we've still in the holding pattern to, we would like to try this other equipment that's a little less capital intensive. But there certainly is equipment out there today that will work on this spectrum. And some of the larger companies like Ericsson and Alcatel-Lucent have that available today. And it's ready, it's working, and so forth. But we've opted to hold off on that. We were looking for something a little less expensive to deploy. So that's the up to this point. That's my presentation, and I would like to turn it over to Tamara. And then, of course, like Mary said, if you've got any questions, feel free to write a question in there, and certainly try to answer it. But Tamara, go ahead.
Thank you very much, Kevin. This is Tamara Johnson with Dryad Communications, and also here with me today is Henry Lickstein, my business partner. And so we'll be sharing with you what we have been doing with 700 megahertz frequency and providing broadband in rural areas. And we'll be telling you a little bit more about some of the stuff Kevin brought up with respect to the spectrum and access to the spectrum, and then stepping through specifically systems that we put up to date, a little bit more about the technology we're using. And as Kevin had said, part of the benefit of using a 700 megahertz spectrum is the wide range. So you'll see some pictures of the range available for systems that we have put up to this point. And I have a few of the names there on the participants list. So I know you guys can't talk back, but good to see a few of you from having talked to you before. We wanted to give you a map of the 700 megahertz ownership in the state of Minnesota. And as Kevin had showed you, he was specifically focusing on the spectrum that his company has. You see here the A band ownership. So also, as Kevin was saying, the frequency, the 700 megahertz, there's a lower 700 and upper 700. We were focused here on the lower 700, and it's broken into A, B, and C bands. And so this first picture you see is on a county-by-county basis who it is that owns the spectrum. You will note, as we step through each of these pictures for A, B, and C band, there are major carriers that own a significant portion of it. In this case, for the A band, Verizon owns a large chunk, but you'll also see who owns the spectrum in other areas. And as Kevin had said before, you know, the spectrum was auctioned off. People have purchased it. Spectrum does change hands periodically. Spectrum can be leased out by those who own it. And so to the question of how do you get to the spectrum, you figure out who owns it in your particular area of interest, and then figure out if there's opportunity to work with them, either through a leasing arrangement or if there was a reason to do so through purchase of the spectrum. But this gives you a feel for, at least in the A band, who owns spectrum in what particular county. And on the next page, you will see a map of B band ownership. The A band is broken out in different chunks than the B and C band. If you were to look at on a chunk-by-chunk basis, you would see this. But in the B band, AT&T has most of the state of Minnesota, with another company, Skycom, having a portion of it over to the west. And then finally, the C band, and this includes the portion that CTC has. And Kevin, we noted we had missed half of Cass County, so sorry about that. We had included that as AT&T's ownership. But allows you to see who had picked up the spectrum, or since the auction occurred, who has purchased it from someone else in each of these different areas. And back to Kevin's link to wireless.fcc.gov, that is the source of this data. No, it is not easy to figure out, but the data is public data that's available once you figure out how to access it. A little bit more about Dryad Communications. We're in the business of providing fixed wireless broadband, specifically using the lower 700 spectrum and using a DOCSIS technology that I'll tell you more about in a few minutes, that allows us to provide 15 to 25 miles radius coverage from a base station install. And when we are doing this, we've tried to, as much as possible, use existing infrastructure. So we're utilizing existing towers, existing fiber, or using over-the-air microwave for backhaul. And so trying to take advantage of other investments that have already been made to allow us to then extend the footprint of broadband to reach in areas that may not make sense to build out in another method, but do make sense once you have the range that you can get using the spectrum. To give you a feel for the number of customers you can serve, you can get up to around 200 customers per base station install, offering what we consider broadband speeds, or what people define to be broadband, so adequate speeds for people to use the internet, watch videos, do those types of things. But it is true, as Kevin pointed out earlier, you are limited in the bandwidth that you have. And so in this case, it's an aggregate 27 megabits that you are sharing amongst those users. Right now we have a couple systems that are up in South Dakota and Nebraska. And specifically, those systems are providing service to two tribal lands, the Santee Sioux and the Rosebud Sioux. In some cases, there are customers that are beyond the tribal lands that are also served by the systems, but the systems were put into place specifically to provide service in those areas. We are looking at other areas of South Dakota and have been working on other opportunities in the Black Hills area specifically, and are making some decisions about what we want to deploy there. And then some folks will recognize our names and voices because we do have some efforts underway in Minnesota. As you guys understand, the winter has not been kind to us, and so things are a little bit further behind than we had anticipated they would be by this point of the year. But we will have some systems up and running in Minnesota as well. What you see on this page is a depiction of a wireless DOCSIS system. And one thing to say, wireless DOCSIS is repurposing of equipment and technology that's been used in the cable industry. And so it's taking things that were, in hardline cable industry and instead using them to deliver internet over the air, basically. And so equipment, if people are familiar with equipment and hardware using the cable industry, they'll recognize some of the names. Specifically in this box on the lower left-hand side, that's the components that are at the base station. So everything in a light blue is what you would find at the bottom of the tower. You have an antenna, of course, that's on the tower that allows you to then send and receive the signal. And then the bottom right-hand side is the equipment that you have at an individual's home. And so since this is using old UHF channels, the antenna that's at a customer's house looks very much like a TV antenna, so kind of similar to what we were used to seeing in the past. And then you've got a transceiver and a modem that's in their house. And so it's a minimal set of equipment, really, that's at the customer site. but you do have to put that up at each location, whether it be a residence or a business. And then the left-hand side there, you know, the green at the top is just depicting the fact that this does tie back into the greater internet, and you're able to monitor and control things remotely. Doesn't matter where you are. To give you a physical feel for what things look like that were depicted on the previous page, here are some actual hardware installed. The left-hand side is equipment that you would have on the tower. It specifically is the equipment that's off to the right-hand side of the tower there. The things on the top are something else, and the antennas below are something else, but the monopole antenna to the right. You see in the middle the rack of base station equipment. So that's the various boxes that had been depicted on the previous page. That's what you'll have at the base station itself. And on the right-hand side is an example of one of the customer premise sites where you have an antenna that needs to be pointed back towards the base station, and then have the associated equipment that was shown on the previous page. To give you a feel for the area coverage that you get, as well as the impact of what the actual happens on the ground, we show you here our Santee area coverage map and our Rosebud area coverage map. So the Santee reservation on the left-hand side is actually on the Nebraska side of the border with South Dakota. The spectrum that we are utilizing there is primarily a couple pieces across a good part of South Dakota, but the spectrum also extends some into Nebraska and counties of neighboring states. And so in this case, the reservation, majority of the people on the reservation live there right along the lake. And so there was a site that we were able to take advantage of that allowed us to cover, I think it was like 80-something% of the folks in the reservation, but then also allowed us to extend a great distance into South Dakota. And because of the way the land goes on the reservation itself, signal doesn't extend any further because the hill goes up and the tower is only so tall. But where we are on a bluff that allows us to see quite far. Shown here, the circle has a radius of 30 kilometers, so 18.5 miles, to give you a feel for how far the signal goes. And we have demonstrated up to the edges of the green here, you know, good speeds with the system, doing a mobile testing of it. And then on the right-hand side, Rosebud Reservation, it's a larger number of people. This is also in the southern part of South Dakota, though it's in the middle of the state. And we were able to co-locate on a radio station tower that had favorable placement because just like we want to reach the people, radio stations want to reach the people. And so we were able to reach many of the communities, the major cities, as well as many of the areas that folks live there on the Rosebud Reservation. And once again, you can see we've got a pretty large diameter in this case, you know, 30 miles across the county, that we cover a great part of it due to, you know, the frequency having very good propagation properties and the power we're operating at there. So with that was the prepared material I had. We're happy to answer any questions about the specific projects we've done so far or questions people may have about use of lower 700 technologies, etc.
Do you see the question from Mark? Hi, Tamara. What kinds of speeds do your customers receive?
Yes, thank you. Yeah, the systems we have set up right now, we have two packages that we're selling to folks. One is a 6 meg download and 1 meg up, and we call that our plus package, and then our basic package is 3 megs down and 0.5 meg up. And so when we actually had those numbers on the chart and decided it was getting a little too busy. But back to the chart where I mentioned 200 people that you can get about 200 customers, that's assuming you've got a blend of folks using those speeds. So, you know, something around 50-50 split between those two packages. You know, when people are using internet, they're not all using it at the full speed at the same time and, you know, streaming constantly. You can tell when somebody's streaming movies, of course, but that's the blend of speeds that we're offering and what we found works out fine.
So there's a couple more questions. First short one is, what's the most favorable bands?
Brands or bands?
I'm assuming she means bands. Or maybe she does.
Between, yeah, so assuming
brands,
I'm
sorry.
Equipment. Do you want to, Kevin, do you want to take a start at that, and then we can fill in after you've had your answer?
Well, yeah, favorite. We are looking, the equipment that we're testing right now is AirSpan. They've got an LTE product for this fixed wireless, and but we also know that Telrad has 700 equipment. It used to be Alvarion, but Telrad bought it from Alvarion, and of course you've got Ericsson, which is a very, very large company worldwide, and they sell a lot of their stuff to you know, the big companies. Alcatel and Lucent are the big ones that sell to the large companies and to smaller companies too. But when you get in, I guess when you get into this niche business, I guess, you know, where you're picking little pockets, I would, you know, that's why we're kind of waiting for some of this little less expensive equipment to try to do these pockets, because a lot of places we wouldn't be able to get 150, 200 customers per tower site, so we've got to keep the cost of the equipment down in order to go to 75 to 100 customers.
Do you see Janet Keogh's question?
Yeah,
St. Louis?
And I will take that question. And Janet is informed. So yeah, Cooperative Power is working with us. We are the company that is working with them to provide 700 megahertz. We put the system up right towards the end of last calendar year, and have, you know, I will explain a bit more about your question, but part of our not having rolled it out fully yet has been the challenges of the weather. It is true that the system behaves differently in Minnesota than it does in South Dakota. South Dakota is much flatter and has a lot less growth on the ground of various kinds. We have found that, I mean, we predict and understand hills and valleys and the impact that they have on signal propagation. So you see some of that in these two pictures. Areas you see things dropping out, that's because there was a hill or a valley or something going on there. Trees and humidity, we do understand those some as well, but we had found the impact to be a little bit greater than anticipated in the system we put up. And so we specifically are putting in a piece of equipment that's going to increase the power, the amplification power at our base station than what we had put in originally, and have literally been having to wait for snow to melt to get that piece of equipment back out to the tower and get it up and working. And putting that up will allow us to have additional margin in the system performance and basically allow the link to close in areas that it doesn't close right now. And so we are the folks who are working with those guys and are working on making it specifically work better in the environment in that part of Minnesota.
Sally has, or there's another question for, what about Ubiquity? Yes, we're testing Ubiquity also, but I believe they do not have 700 spectrum, and I'm searching my memory bank what frequency they use. But Ubiquity makes a line of equipment that's very affordable, and it seems to be working well for very niche pockets of customers, and we have not deployed it yet, but we have done a couple of tests with it, and and I believe that's on a higher frequency. They might be using 3.65 or 3.65 or 2.5 frequencies, but Ubiquity is a very formidable manufacturer of equipment. And
Yeah,
I guess, go ahead, Tamara.
I would say that's consistent with our understanding as well. They've got equipment at 2.5 and 5.2. Or 5.8, I'm sorry.
Yep. And a question about national carriers using their 700. They're blending it, as far as I know, they're blending it right into their mobile their towers. The phones are picking up. They're programmed. An AT&T phone is programmed whether to go to the B frequency, C frequency, or on 700, or go to AWS or whatever. That's the way I understand it. They're blending all those frequencies together with technology to get the bandwidth needed for all their data needs. And every time I say something, everybody take it with a grain of salt, because I'm not an engineer. So that's the way I understand it.
Yeah, I mean, it's a little bit, I guess, of a harsh reality, or this is the way it is, but the national carriers are using it across the board as part of their rollout to LTE and, greater speeds and greater coverage and more bandwidth. So the areas that we see, we have talked with the major carriers. It is not easy to get them to want to do something else than what they're doing with it already, because they have a very specific need that they are trying to do. And that's, allow them to capture more of the mobile audience and make more money off of the mobile audience, whether it be phones or tablets or whatever.
And somebody did note that, yeah, I believe Ubiquiti is 365 and 2.4 frequencies. High frequencies, shorter distances, but from what I understand, it's working out very well. 900 megahertz. We have not deployed any 900 megahertz. I don't know, Tamara, if you guys had any experience with 900.
No, we have not. I wasn't sure if somebody was making a comment about Ubiquiti's equipment, or if they were asking a question. Yeah, let's see what Tim says.
Yeah.
Looks like somebody might be typing something, but let's just take, does anyone have any last questions?
Okay, so Tim is pointing out that Ubiquiti also has 900.
Yep. As
well as 5.8.
Yep.
And there's a couple of folks typing.
Well, hopefully we'll get another question here. We will wait a few minutes. I know I've noticed that sometimes when it says people are typing, I think people are considering typing, but maybe they aren't, truthfully.
Anticipated software.
Yeah, right. Oh, there we go. There's a couple new questions if one of you wants to address those.
Pavel, I'm unfamiliar with that question. I do not know what that was about. I apologize about that.
Yeah, there's 365, which is semi-licensed, and what you can do is on a case-by-case basis, or on a specific, this is what we're going to do with it, go to the FCC and say, here is our intent and here is what we want to put up, and they will then give you the okay to go and do it. It is accurate that it's not like they took the U.S. and broke it up into pieces, as you see with the lower 700 spectrum. And I believe it is relatively cheap to go through the process of doing that. It's viable in the sense that, yes, there are people that go and do it. I guess downsides to it would be the propagation capabilities at that specific frequency, as well as the fact that with it being semi-licensed, I don't think there's any guarantee that you won't have interference with someone else. It becomes a bit of the, who was there first, and if you end up having interference, how do you work out who wins or who has to, redirect or turn their system down? So that's the risk of going down that route.
Good catch, Tamara. I apologize. We do have a 365 license, and basically, yeah, you get a piece of paper that says you have the license, but if somebody else puts up some 365, you have to work together to work out your issues. But there's lots of equipment out there that'll run on 365. It works very well. But again, it's a very high frequency. Trees and terrain are issues with that. But we're testing it right on this tower right here in Brainerd as we speak. We've got about 20 customers on it, and they can get 6 to 10 meg down on it, and it's quite stable. But it's in an area where there's no trees, and the minute you move into the trees, it changes that.
Yeah, one other thing. I mean, another reason why would you go for the, license exclusive spectrum as opposed to unlicensed or semi-licensed is that with the license exclusive, you're able to transmit at much higher powers. So in addition to whatever propagation characteristics the frequency has itself, you can propagate at higher powers because it's yours to go and do. And then Sally asked the question, if there's no 700 to be had and it's hard to work with AT&T, what do you do next? Good question. I mean, part of why we wanted to show the A, B, and C is to show that you do have some opportunity in different bands. So depending on who happens to own what you have, or wherever you happen to be, you have 3 possible owners you could be working with. I know, for example, the area around Minneapolis, that's all the major carriers, in the area immediately around there. That's not as rural either, but I'm certain I haven't gone back and looked at it specifically, but just doing a quick, looking at those 3 state maps on the right-hand side, there are counties which are totally owned by major carriers. What next on 700? I guess it's a matter of if you can find the right person in the organization who is wanting or willing to make what you guys are looking for a priority, whether it be fixed wireless or mobile wireless or something else is kind of the best answer I can give.
I think the next one's yours, Tamara, about oversubscription, 200 subs and so forth.
Yeah, we have just a sec. Okay, so that you've got customers that are hitting 9 to 10 megs with only a handful of customers at peak time. Yes, that is a challenge. What we have seen 30 customers getting to the 9 to 10 peak you're talking about.
Tamara, are you on speakerphone?
Go ahead. Oh, are you able to hear me?
You're getting, I don't know if it's just me, but I'm hearing a lot of static behind you.
Yeah, motor boating sometimes. Yeah. I'm not sure where it's coming from.
Did that change in the last? There's construction going on outside, which I was hoping that I'm not hearing.
I think we're hearing it.
Is that a little? I'm closer to the phone.
All right. Okay.
Sorry about that.
Yeah.
What I was saying is we have seen 9 to 10 megs by 30 customers on at one time, and so you might have a little more aggressive customers than we have. Getting the math to work of sharing amongst all of those customers is limiting them on the 3 and 6 packages. I'm telling you the experience that we have had so far that isn't quite as bad as what you were seeing in terms of users and what they're doing. A more general, you can limit their total download within a month and then throttle them back. I know that's a generic answer and doesn't specifically deal with the problem that you're identifying. Anything? I'm turning to Henry to see if he has anything else he wants to say to help better answer this question.
And that's Tim. Hi, Tim. Any shared resource requires either a careful management of expectations on the part of your users or the implementation of certain protocols to limit abuse of the channel by a small number of users. As Tamara was saying, we have a situation where we're watching some users downloading a substantial aggregate amount of information. In fact, we're seeing factors of 4, 10, as much as we expected. But it isn't really restricting the general use because it's spread over time. And by giving speed limitations to any one person based on what they're willing to pay, it forces a time average of their use of the channel. So we think that the 27 meg, we wish it were greater than the effective throughput of 27 megabits that's possible in the 6 megahertz RF channel using the wireless DOCSIS modulation protocol and modulation. But we find that it is very effective in providing service to a moderately large number of people.
And Henry, really what you're saying is, and what people have to understand, when you get into this business, you just don't open up the water gates and let water flow. You actually have to have people and the tools and the instruments to be able to monitor this and manage it, because you will have people that will abuse it, and you've got to control that, or else it destroys it for everybody else. And so you've got to have Tamara showed an NOC, a NOC center, Network Operations Control. That's where you've got the brains of a network to help monitor it, and it'll identify when you've got problems in your network, and then you have to manage those, either through pricing or limitations or whatever. But I think that's really the key here, that you have to manage the network once it's up.
Well, and Kevin, your answer is of course correct. In addition, there are appliances, that is devices you can connect to your network, or you can implement in software various protocols which monitor the individual user's use, and you both throttle the speed at any instant of time, and you track how much aggregate data the user takes down. There's a strong antipathy toward having data caps, but certainly the satellite users and cell phone users are comfortable with data. They're not comfortable, they hate them, but
they have them.
They have them. They live under data caps, and what you'll find is that the abusers in your network number between 3 and 5% of the total, and so you are better served if your pricing and if your public discussion of what your limits are allow you to not cut off, that's not a viable alternative, but throttle back in speed to a lower level, maybe 1/5 of the maximum they contract for. So that if they try to take down too much data in a short period of time, they find that their speed is cut back. And the users understand that to the point that they try and game you, to the aggressive ones. But by and large, 95% of your users will be aggressive users or not, but they won't abuse you. And so it does work. There is a quasi-technical question of where does the 27 megabits come from. It's the math that is made possible by whatever equipment you are using to modulate the signal, the analog signal in RF. And the more complicated the technology you use, the more throughput you get. With wireless DOCSIS, we're able to go up to what's called QAM64, and QAM64 allows us effectively to put 27 megabits of data in a 6 megahertz channel. As Kevin was alluding, LTE uses more complicated both technology and math, but they generally have been built for 10 megahertz channels, and they get larger megabits, but they do not at this point in time have.
I think we lost you, Henry.
Lost me technically or lost me audio?
Oh, no,
lost your audio for just a moment.
Yeah. So.
Okay, he was close to done. Finish your sentence.
Yeah. No, I'm sorry. So it's just the 27 megabits is a limitation based on the technology used to modulate the 6 megahertz.
All right.
And the airspan equipment that we're testing, if you got 10 megahertz channels, you know, there's about 60 megabits of usable space. So that just kind of gives you what those algorithms and formulas and equipment get quite sophisticated, but that's what they do with the new LTE stuff.
Are there any last questions today? I don't see anybody typing. Presenters, do you have any last final thoughts to share, or else we'll just wrap up?
Well, I've been in the wireline business for over 35 years, and getting into the wireless business is just totally different. And I'm not trying to scare anybody, but it's not as predictable. You saw the maps that Tamara shared with you, and you see the spotty areas. We put up a 3.65 radio over here at Crosby. There's lots of iron, lots of hills, lots of trees. It basically, and from the computer propagation maps to on a piece of paper compared to it working, there was a tremendous disappointment in the ability for that 3.65 to travel. We have not put 700 over there yet because it would interfere with a couple other towers. So just be mindful that whatever frequency you use, everything has pros and cons to it, and it's getting more and more sophisticated, and then you haven't even yet connected to a network. So it's an interesting business. It's exciting. But it's still, I believe we're evolving into the next generation of equipment, and we're just, in our minds, we're still on this path when we're not sure which way we're going to go yet at CTC. It's difficult to make these decisions, and it takes a lot of capital.
Okay. I'll just read what Julie Foote here wrote. Not predictable, but gratifying. Customers are so happy when they finally get true broadband. Okay,
I mentioned my SOMA equipment is obsolete, but I got almost 800 customers around 5 different areas, and they're not disconnecting when they only can get 768. Now I'm not proud of the 768, but it's still better than nothing. So Julie's exactly right. And these people are very tolerable because they're very appreciative of any broadband. So
right, and I would echo that in our customers we have in South Dakota, Nebraska, and as well as the cooperative light and power location. We do have some folks there that have had service since December, and it's worked fine the whole time, and they've never had service before, and they absolutely are happy and enthusiastic when they are able to, you know, finally get broadband speeds and get on the internet.
All right. Well, thank you, Kevin and Tamara and Henry, for joining us on the webinar today. Our next webinar will be Thursday, May 8th from 3 to 4 p.m. The topic has yet to be confirmed, but we will be soon. Thanks, everyone, for attending, and have a great rest of your day.
Thank you.
Thank you.